Hybrid dinosaurs have become a good portion of the hype surrounding the dinosaur community for a good while now. Ever since Jurassic World introduced the Indominus Rex in 2015, wow, that was 11 years ago, the idea of dinosaurs mixing and matching like biological Lego sets has exploded across the internet. YouTube channels such as Goji Center, Goji Guy, and countless others regularly imagine terrifying crossbreeds. There are of course the community classics like the Spinosaurus fused with the Tyrannosaurus, and raptors spliced with anything sharp enough to make it deadlier. Hybrids have become a staple for bigger, smarter, and deadlier. But once the cinematic smoke clears and the algorithm quiets down a bit, a surprisingly serious question remains. Could dinosaur hybridization have actually happened in the real world, long before humans ever dreamed of resurrecting them? G'day mates, hope you're doing well. Today we're covering if naturally occurring dinosaur hybrids may have actually been a thing in real life. As always, make sure to like and subscribe so I don't end up extinct like the creatures in these videos, and let's jump into it. A hybrid, stripped of Hollywood drama, is simply when two species interbreed and produce offspring. It's not science fiction, it's simple biology. Wolves and coyotes hybridize so frequently that many of their populations have blurred together. But they aren't the only examples. There are of course a large number of species today that are known from hybridizations. Grizzlies and polar bears make roller bears. Big cats have a whole variety of different hybrids including the liger, jaglion, leopon, and many more. There are of course the 7 seas which even hold the wolfen. Birds in particular hybridize constantly, so much so that some ornithologists often struggle to find a clear species boundary. Reptiles also have a few hybrids up in their sleeve. From a biological standpoint, hybridization is not an exception to evolution, it's one of its tools, and that immediately makes the idea slightly less absurd when applied to dinosaurs, which, as we know, weren't movie monsters but animals shaped by the same evolutionary forces that we see today. First things first, as always, dinosaurs existed for an almost incomprehensible length of time, being over 160 million years. To put that into perspective, modern humans have only existed for about 300,000 years. Many modern animals have varied species existence, with some being a few million years to a few 100,000 in others. Meanwhile, many species of dinosaurs existed for well over a million years, broadening this idea. So when you think about it, if hybridization can occur among animals in just a few million years, then dinosaurs would have had more than enough time for it to happen repeatedly and repeatedly. They also lived in ecosystems packed with closely related species. Late Cretaceous North America alone was home to multiple species of horned dinosaurs, duck-billed dinosaurs, and large theropods, all of which overlap in space and time. These were not isolated lineages that were neatly separated by geography, they were neighbors, and where related species did coexist, hybridization becomes a possible outcome. Time and proximity alone, however, are only one part of the equation. For hybridization to actually occur, animals must recognize one another as potential mates. In modern ecosystems, closely related species often share similar courtship behaviors, vocalizations, or visual displays, which can blur mating boundaries, especially during time of environmental stress or population imbalance. Dinosaurs, particularly those that were highly social, like ceratopsians and hadrosaurs, likely relied on visual displays such as horns, frills, and crests to communicate dominance and reproductive fitness. If those signals were similar enough between species, occasional cross-species breeding would not only be possible, but biologically plausible. The problem is that fossils are terrible at preserving the evidence that we would need to confirm it. Hybridization is usually detected through genetics, DNA, chromosomes, and patterns of inheritance. But dinosaur DNA does not survive tens of millions of years. What we're left with are the fossils that remain, and they only can tell part of the story. When a paleontologist finds a dinosaur fossil with a mix of traits, let's just say a horn shape that doesn't quite match any other known species, it raises eyebrows, but it doesn't necessarily provide a smoking gun. You don't go ahead and uncover an ultra rare specimen and straight away go, yep, that is a hybrid. More likely than not, it could simply be natural variation, sexual dimorphism, or a juvenile that hasn't quite grown into its adult form. In paleontology, extraordinary claims demand extraordinary evidence, and hybridization rarely leaves extraordinary bones behind. Still, some dinosaur groups are suspiciously messy in ways that feel familiar to biologists that study living animals. But the strongest argument for dinosaur hybridization does not come from the fossils at all. Instead, it comes from their closest living relatives, this being birds and crocodilians. Birds, of course, are living dinosaurs, direct descendants of small feathered theropods that split off during the Jurassic period. hybrid. And as previously mentioned, birds hybridize all the time. This is to the point that 16% of wild bird populations are known to being capable of hybridizing with another species of bird. Ducks are notorious for it, finches hybridize frequently, and in some cases, hybridization can actually accelerate evolution rather than halting it. Of course, we cannot forget about the crocs, and with them there are a fair few, including the Cuban and American hybrid, Siamese and saltwater hybrid, and even the speculative Nile and saltwater hybrid. So if modern relatives of dinosaurs retain this biological flexibility, in my opinion, it is difficult to argue that their ancestors completely lacked it. Gene flow between closely related species can introduce beneficial traits, increase genetic diversity, and even stabilize populations facing environmental change. In rapidly shifting ecosystems such as those characterized by the Mesozoic, if similar events occurred among the dinosaurs, hybridization may have subtly influenced their diversity, resilience, and evolutionary outcomes without leaving obvious traces in the fossil record. Of course though, this is where Jurassic World can fundamentally confuse some people. The hybrids in those films are not the result of natural hybridization, but extreme genetic engineering. I mean, they were splicing animals separated by tens of millions of years and entire families. If dinosaur hybrids existed, they would not have been grotesque super predators stitched together across families. They would have been subtle, animals that if reached adulthood looked mostly normal and went unnoticed even in their own time. When we strip the idea of hybridization down to its biological requirements, timing and geography becomes just as important as anatomy. As a result of not knowing how distant some dinosaurs may have actually been when they are anatomically similar, the requirements I have that two species don't just need to be closely related, they need to have coexisted or at the very least been close enough in time and space for interbreeding to have been possible. Now some of you may bring up the sturddlefish, and if you don't know what that is, it is a fish born from the American paddlefish and Russian sturgeon. Now their common ancestors split off around 140 million years ago, yet they were able to reproduce. However, it is speculated that these fish, despite the large time difference that separated them, obtained few genetic changes which allowed them to interbreed. So as sad as that might be to some people, this immediately rules out popular pairings like Spinosaurus rex and Stegoceratops. The more compelling candidates are dinosaurs that are within the same family order during the same narrow window of time. In my opinion, the ceratopsians are one of the strongest cases when viewed through this lens. The key example has to go to the two units of the Hells Creek Formation, this of course being Triceratops and Torosaurus. Think about it, both lived in the same regions of western North America at the very end of the Cretaceous. They overlapped in both time and habitat, they browsed on similar vegetation, reached comparable sizes, and differed primarily in skull opening and frill shape. Even today, some debates continue over whether these differences reflect distinct species, growth stages, or variation. That mystery itself highlights how thin the line was between the two species, and in modern animals, such thin lines are exactly where hybridization tends to occur. Hadrosaurs provide another compelling cluster, particularly the Lambeosaurians of the late Cretaceous North America. Corythosaurus, Lambeosaurus, and Hypacrosaurus not only were very close in time, but lived in very similar ecosystems. The differences lie largely in the shape and size of their hollow cranial crests, being structures thought to be used for displaying communication rather than survival. This makes this group biologically plausible candidates for occasional hybridization. Among larger theropods, a cautiously similar case can be made within the Allosaurids of the late Jurassic. Allosaurus fragilis and Allosaurus jimadense are known from overlapping strata within the Morrison Formation of western North America. These theropods would have shared the same environments, race, species, and overall body plan. The differences used to separate them are subtle, largely involving skull proportions in specific bone features rather than dramatic functional changes. In modern large carnivores such as bears, when population densities reduce, the frequency of hybridization seems to increase. So over the millions of years represented by the Morrison's ecosystem, rare interbreeding events between closely related allosaur species seems at least plausible to me. Even among the lightly built herbivorous or omnivorous dinosaurs, overlaps create some of the most compelling hybridization scenarios. Ornithomimids such as Struthiomimus and Ornithomimus, which lived again in late Cretaceous North America, occupied remarkably similar ecological niches, sharing body proportions, diets, and high-speed lifestyles. The anatomical differences used to separate them, primarily in limb proportion, torso size, and hand structure, are relatively minor and in some cases difficult to assess due to incomplete specimens. This has led to a long-standing debate over their taxonomic boundaries. In modern animals, especially birds, social species with overlapping ranges frequently hybridize when when reproductive barriers are weak. If similar behaviors apply to ornithomimates, occasional gene flow between related forms like Struthiomimus and ornithomimates would have been possible. Taken together, the most plausible dinosaur hybrids are not dramatic cross-family combinations, but near neighbors. Animals already walking around the same ground, eating the same food, and responding to the same environmental pressures. If hybridization did occur, it likely happened quietly at the edges of species boundaries. Rather than rewriting dinosaur evolution, hybridization would have subtly blurred it, reminding us that prehistoric ecosystems were just as complex, messy, and biologically flexible as those that we see today. So could dinosaur hybridization have ever happened? Based on what we know today, the most honest answer from my perspective is, well, yes, and it probably did happen, at least on very rare occasions. The biological conditions were there, the timescale was vast, and what we so colloquially title as modern dinosaurs, aka birds and crocodiles, already demonstrate that exact mechanism. I mean, considering that growler bears, wolfins, and golden crowned mannequins occur in the wild today, it wouldn't make sense for it not to occur all the way back then when times were tough. What we lack is proof, and to be honest, we'll likely never find it. Fossilization is rare. Hybridization is also not only rare, but leaves faint evidence, and 66 million years is a long time for evidence to disappear. This video is not about certainty alone. It is a speculation about the plausibility supported by modern patterns, and the pattern we see across life, past and present, suggests that dinosaurs were not the rigid, isolated species that we always imagined. Instead, they were likely part of a dynamic and at some stages interconnected evolutionary world. In the end, in relation to dinosaurs, I think that this story is very much undertold. Dinosaur hybrids, if they existed, were not monsters created in laboratories. They were animals navigating, surviving, and reproducing, just like everything else that has ever lived on this planet. And to me at least, that makes the prehistoric world feel slightly less alien and a lot more unique. So yeah, I think that during very rare situations, dinosaur hybrids may have very well walked our planet, just not in the form that you may originally have thought. Anyways though, with that, we've reached the end of the video and I hope you've all enjoyed. As always, don't forget to like and subscribe, and I'll catch you all in the next video. See ya mates!